Now talking about the respiratory volumes and the capacity, students. So if we have it on graph, so this is the expiratory reserve volume, the residual volume, the total lung capacity. Suppose this is the total lung capacity, then this is the inspiratory reserve volume, this is the total vital capacity, this is the expiratory reserve volume, this one is the residual volume, and this is the tidal volume. Now, understanding the tidal volume first. The tidal volume is the volume of the air that is inspired or expired with each normal breath that's involuntarily. That's called as the tidal volume. In normal person, tidal volume is like 500 ml. Now talking about the inspiration reserve volume, IRV, it is defined as the extra volume of the air which can be inspired by the deepest force, the inhalation beyond the tidal volume. Inspiratory reserve volume, the IRV, it is also known as the complemental air volume and is about 3000 ml. And the next is the inspiratory capacity. How do we measure that? So it's the total volume of the air that can be inhaled forcefully after a normal exhalation. So IC equals TV plus IRV, which is a total of 500 plus 3000 gives 3500 ml. And now talking about the expiratory reserve volume, ERV, it's the extra amount of the air that can be expired forcibly after a normal expiration. It's about 1100 ml. And talking about the residual volume, RV, it is the volume of the air which remains still in the lungs even after the most of the forceful expiration. It is about 1200 ml. Now students, we will be taking a look at the respiratory volumes and capacities. So in here, the functional residual volume, that is FRV, how do we find it, or how do we know what is it? So it is the amount of air that normally remains inside the lungs after a normal expiration. Now talking about FRP, it is equal to the sum of the expiratory reserve volume and the residual volume. As you can see, this is the residual volume, this is the expiratory volume, and they are exactly equal. Now, if you happen to make a formula for FRV, then ERV plus RV gives you FRC, and it is about 2300 ml. Now knowing about that vital capacity of lungs, the vital capacity of lung, or VC, it is a maximum amount of the air that can be expelled from the lungs by the forced exhalation after the deepest inhalation. Vital capacity of lung is equal to the sum of the tidal volume, inspiratory reserve volume and expiratory reserve volume, as you can see here. This is the vital capacity, and it is exactly the same of the sum of the inspiratory capacity and expiratory reserve volume. Inspiratory reserve volume and expiratory reserve volume. Now if we happen to make the formula for this, how do we formulate? The formula for vital capacity is vital capacity equals TV plus IRV plus ERV, which gives a total of 500 plus 3000 plus 1100, which makes a total of 4600 ml. Vital capacity is higher in the mountain dwellers, students, athletes, young persons and men. So if you want to become a great athlete, then do practice at higher altitudes wherein your vital capacity is going to increase. If you are very interested, you can read about Michael Phelps. He was someone who in the Olympics got 10 gold medals, and the reason behind his great success was that he went for an year at a higher altitude and practiced there, because of which his vital capacity and his lungs became so strong that his capacity, overall performance improved and enhanced. The total lung capacity, that is TLC, it is the total amount of the air that can be present in the lungs after a maximum inhalation effort. So the total lung capacity, where do you see the total lung capacity? This is the total lung capacity. The total lung capacity is the total amount of the air that can be present in the lung after a maximum inhalation effort. The total lung capacity can be worked out as the total lung capacity equals VC plus RV, or you can say TV plus IRV plus ERV plus RV, which is like 5 minus 6 liters. That's an average of 5,800 ml.